Hi everyone. Today we are going to present on the topic of supervised learning. So what is these are the concepts we are going to present. So what is supervised learning? So as the name indicates, it has a supervisor as a teacher. So basically the supervised learning is when we teach and train the data which is already labeled. So which means some data is already tagged with some correct answers. So after that the machine is provided with a new set of examples so that the supervisor algorithm analyzes the training data set. So and the next thing what it is unsupervised learning. So it is a fully opposite of the supervised learnings. So in unsupervised learning, the training of the machine information that is neither classified nor labeled and allows the algorithm to act on the information without any guidance. So basically the supervised learning has two steps. One is learning and testing data sets. So the learning is a model used to train the data, like which is used to train the data that and again it is tested. So the test model using unseen test data is to access the model accuracy. So the accuracy of the data is calculated by using the number of correct classifications by total number of the test cases what is used. So, and the one of the most used supervised learnings is decision tree algorithm. So, in the decision tree algorithm is used for the classification of the trees. So, decision trees are the types of machine learnings, and it is used to which is used to produce a corresponding output of the training data. And in this, the data is continuously splits into according to the parameter. The data is splits into a tree. So this is a basic algorithm what is used in the decision tree. The decision tree algorithm used is an divide and conquer algorithm. So it is constructed in such a way that top-down recursive manner. So there are some conditions for stopping the partitioning in the decision trees. For example, all the example for the given node is belongs to the same class and there are no remaining attributes for the further partitioning. So if there is no further partitioning is allowed, so then we can stop the partitioning of the algorithm. And there are some evaluation methods also used in the supervised learning. So one is a holdout set algorithm. So in this the data is divided into two disjoint subjects. One is training data set and another one is test data set. The training is used for the learning models whereas the test is used for the testing models. So one of the important point to note in the evaluation method is the training set should not be used in the testing and the test set should not be used in the learning models. So and this evaluation method is mainly used for the data set which is large. So next, classification measures. There are some classification measures used to build the accuracy of the decision of supervised learning algorithms. So in the text mining, we may only be interested in the documents of the particular topic, which are only a small portion of the big document collection. So there are some the like using the class of interest also we can use it as in classification measures. So this class of interest mainly have the positive class and rest is defined as a negative class, so that the positive class has a more accuracy than compared to the negative classes. So next is continued by my friend.
Hi, my name is Priyanka. So for classification using association rules have three approaches. The main three approaches for these are using association rules to build classifiers, using class association rules as attributes or features, using normal association rules for classification. So coming to the one approach where we use class association rules for the classification is mining a small set of rules existing in the data to form a classifier or predictor. So it has a target attribute as a class attribute. And for the association rules, it has no fixed target, but we can fix a target using the classification association rules. It has a target class attribute example as given here, where we have own house assigned with true. It gives the class as yes with the support of 6 by 15 and configuration of 6 by 6. Cars, I mean the class association rules can obviously be used for classification. Next comes the decision tree versus this class association rules. The decision tree below generates the following three rules. So and but there are many other rules that are not found by this decision tree. And we have naive Bayesian classification, which has a probabilistic view, which the supervised learning can naturally be studied from the probabilistic point of the view. So given a test example D with observed attribute values A1 through AK, the classification is basically to compute the following posteriori probability. The prediction is the class Cj such that probabilistic of the C is maximal. Computing probabilities, the demonstrator is irrelevant for decision making since it is the same for every class. We only need probabilistic of A for the C is equals to Ci, which can be written as the following way, and recursively the second factor above can be written in the same way, and so on. So an assumption is needed. On naive Bayesian classifier, advantages are it is easy to implement and it is very efficient. It is also returning good results obtained in many applications. Disadvantages are there is an assumption that class conditional independence, therefore loss of accuracy when the assumption is seriously violated. That is, those highly correlated data sets. Text classification or categorization. Due to rapid growth of online documents in organizations on the web, the automated documented classification has become an important problem. So techniques discussed previously can be applied to the text classification, but they cannot be as effective as the next three methods. So we first studied a Navy Bayesian method specifically formulated for text, which makes use of some text-specific features. However, the ideas are similar to preceding method. The probabilistic framework, where generative model, which is an each document is generated by a parametristic distribution governed by a set of hidden parameters. The generative model makes two assumptions, that is, the data are generated by a mixture model. There is one-to-one correspondence between mixture components and document classes. Mixture model. So this model is the data with number of statistical distributions. Uh, each distribution corresponds to a data cluster, and the parameters of the distribution provide a description of the corresponding cluster. So each distribution is a mixture model is also called as mixture component. The component can be of any kind. So next will be continued by my friend.
Hello, myself Vivek. Now I'm going to continue. The topic is support vector mission introduction. Support vector mission introduction were invented by Wapnick and his co-workers. Uh, SVMs are linear classifiers that find a hyperplane to separate two classes of data, positive and negative. Kernel functions are used for nonlinear separation. SVM not only has a uh, retrogenous theoretical foundation but also performs classification more accurately than most other methods in applications, especially for high dimensional data. It is perhaps the best classifier for text classification. KNN algorithm compute the distance between D and every example in D. Choose the K example in D that are nearest to D. Denote the set by P belongs to D. Assign D the class that is most frequent class in P. K is usually chosen empirically via a variable validation set of or cross validation by training a range of k values. Distance function is crucial but depends on applications. This is example of KNN where uh, these green dots are government and red dots are science and white dots denote arts. Yeah, where k is equal to 6 in this example, blue dot is a new point. It is science which to which that blue, we have to know the to which the blue dot belongs to. As the k is equal to 6, we will draw a circle with length of 6, and the dots, the most number of dots nearest to the blue one, one is counted. So most number of dots, one are in this are green, so the blue dot belongs to government. Canon can deal with the complex and arbitrary decision boundaries. Canon is slow at classification time. Canon does not produce an understandable model. Combining classifiers. So far, we have only discussed individual classifiers, how to build them and use them. We can we combine multiple classifiers to produce a better classifier? Is sometimes we discuss two main algorithms, bagging and boosting. Now I'm go with bagging. Bagging. Application of bootstrap sampling. Given a set D containing M training examples, create a sample SFI of D by drawing M examples at a random with the representation from D. SFI one of size M extended to leave out 0.31 of examples from D. Bagging training. Create k bootstrap samples s1 s2 and go on to sk. Build a distinct classifier on each si to produce k classifiers using the sample learning algorithm. Testing. Classify each new instance by voting of the k classifiers equal weights. Now boosting. A family of methods. We only study ada boost training. Produce a sequence of classifiers. Each classifier is dependent on the previous one and focus on the previous one's errors that are incorrectly predicted in previous classifier are given higher weights. Testing. For a test case, the results of the series of classifiers are combined to determine the final class of the test case. These are the quiz questions. Please look into it and answer them. Thank you.